So, away from balancing equation, we look at reactions in chemistry. What are reactions? A reaction is said to occur when two or more substances chemically combine. Now, when we talk about substances coming together, they could be mixtures, compounds, or elements. And when these substances chemically combine, they lead to the formation of new substances called products. So, the substances coming together to combine chemically are called reactants. And reactants will give products. Still talking about reactions now, it is worthy to know that there are different types of reactions in chemistry. These reactions include combination, decomposition reaction, displacement reaction, double decomposition reaction, catalytic reaction, reversible reaction, thermal reaction, and lastly, oxidation reduction reaction, which is also called redox reaction. Let us therefore take a look at these types of reactions one after the other. The first we shall be talking about is combination reaction. Combination reaction can be between two or more elements. When elements chemically combine, they lead to the formation of a compound. Good example of this kind of combination is when magnesium bonds in air. That is to say, magnesium reacts with oxygen to give magnesium oxide. We are not really interested in balancing the equations here, but just to make us understand what happens between two substances coming together to give a compound. Hydrogen can also go into reaction with chlorine to give hydrogen chloride. Sodium coming together with chlorine to give sodium chloride. And iron will react with sulfur to give iron 2 sulfide. So these are examples of combination reaction. We have the next type of combination reaction, which is between compounds. When two or more compounds come together, they give a bigger compound. Good example is, as we can see displayed, we have lead 4 oxide plus sulfur 4 oxide to give PbSO4, that is lead sulfate. In the next equation, we have calcium oxide reacting with water. That is, when calcium oxide is being slaked, it gives the slake lime, that is calcium hydroxide. We also have aluminium reacting with sodium hydroxide to give sodium tetrahydroxoaluminate 3. That is a complex compound. We also have magnesium oxide reacting with carbon 4 oxide to give magnesium carbonate. So these are instances where two compounds coming together to give a bigger compound when they react. Away from combination reaction, let us take a look at the next type of reaction, which is decomposition reaction. When we talk about decomposition reaction, as the name goes, decompose. Decomposition simply means the application of heat. That is to say, the compound is being broken down. So decomposition reaction is a type of reaction in which a given compound is broken down as a result of the application of heat. When these compounds split, it brings about the formation of different compounds. So these are examples of decomposition reaction. Lead nitrate decomposes when heated to give lead 2 oxide plus nitrogen 4 oxide, and oxygen gas is liberated. When potassium nitrate decomposes under heat, it gives potassium dioxonitrate 2 plus oxygen. In the third equation, calcium triazonitrate 5, or simply call it calcium nitrate, will decompose to give calcium oxide, also known as quicklime, plus oxygen and nitrogen 4 oxide. We all have magnesium carbonate decomposes to give us magnesium oxide plus carbon 4 oxide. So these are examples of decomposition reaction. Once again, a decomposition reaction takes place when heat is applied to a compound, making such compound to break down or split to simpler compounds. So away from decomposition reaction, let us take a look at our next type of reaction called displacement reaction. Looking at the equation representing displacement reaction, from its name, displacement, A reacts with By to give the product Ay plus B. That simple equation simply tells us that A has displaced B. It simply tells us that A displaced B in that equation. A is able to displace B probably because it is more reactive than B, or has more affinity for Y than B. So a displacement reaction is a kind of reaction in which an element displaces another element or radical in a given reaction. It is worthy to note that for an element to displace another element in a compound or in any given reaction, such an element coming to displace the other must be higher than it in the electrochemical series. Now, talking about electrochemical series, I would like to refer you to our lesson on electrochemistry. So check out our video lesson on electrochemistry to recall and understand better what we meant by electrochemical series or activity series. In that lesson, we talked and explained more on reactions looking at electrochemical series. That is, we made reference to the electrochemical series, where a given element will be able to displace another element in any reaction or when they are being electrolyzed. So displacement reaction here tells us that for an element to displace another element, it must be higher than it in the electrochemical series. Let us therefore take a good look at the electrochemical series. Brief introduction again to the electrochemical series. The electrochemical series is simply an array of cations and anions, which tells us the strength of different cations. So looking at what we have displayed, we have the cations which are electropositive. So beginning from silver upwards, you can see that electropositivity increases, which means that potassium is most electropositive and silver is the least electropositive cation. In the side of the anions, fluorine is the most electronegative anion, and the hydroxide ion OH is the least electronegative anion. So looking at the electrochemical series, it tells us that some elements are more reactive than the other, and as such, when they meet lower elements in any reaction, they are able to displace it out of that reaction and take its position. So potassium, being most electropositive, seems to be more reactive than sodium, sodium than calcium, calcium than magnesium, magnesium than aluminium, aluminium than zinc, zinc than iron, and it goes on and on. So having seen the electrochemical series, as a reminder, let us take a look at some examples of displacement reactions. So looking at the displacement reaction, we have zinc reacts with copper sulfate. When zinc reacts with copper sulfate, it gives us zinc sulfate plus copper. So looking at what we have there, the first equation is between zinc plus copper 2 sulfate, and that gives us zinc sulfate, zinc tetraoxo sulfate 6 plus copper. So this simply tells us that zinc has automatically displaced copper and took the position of copper. So it is no longer copper 2 sulfate but zinc sulfate, and copper is displaced out of that solution, that salt solution. So this is an example of what we refer to as a displacement reaction. In the second equation, chlorine reacts with potassium bromide to give potassium chloride plus bromine. That is to say, chlorine has displaced bromine. And if we are to take a look at the electrochemical series once again, we'll see that chlorine is more electronegative than bromine. And we can see their position. Looking at zinc also, in the electropositive element side, zinc is more electropositive than copper. Zinc is higher up, copper is below. So that is why zinc can knock off copper, or we can use the word displace copper from any reaction where it meets copper. So this is an example of what we refer to as a displacement reaction. Similarly, in equation 3, we have magnesium reacting with HCl to give magnesium chloride plus hydrogen. So magnesium automatically has knocked off hydrogen to take its position. So the compound that was initially HCl will no longer be HCl but MgCl2, because magnesium has knocked off hydrogen from the reaction. Now let us go down to the fifth equation. Silver plus copper nitrate, and the result is no reaction. The question is, why is it no reaction? Looking at the electrochemical series, copper is higher than silver in the electrochemical series. So for that reason, when silver comes into reaction with any copper salt solution, there will be no reaction because silver lacks the strength to displace copper, since copper is higher than silver in the electrochemical series. So this is why it is said that for an element to displace another element, it must be higher than that element in the electrochemical series. So this is displacement reaction. Let us take a brief look at a description of displacement reaction. Looking at the experiment as displayed, it is an experiment that is between copper and iron. An iron nail is being dipped into a test tube containing copper 2 sulfate. An iron nail is being dipped with a thread into a test tube containing iron 2 sulfate solution, containing copper 2 sulfate solution. And after some time, the blue coloration of copper 2 sulfate turns light green, telling us that iron has displaced copper from that solution to take its place, and it is now iron 2 sulfate solution. So what is simply happening in that reaction is iron coming into reaction with copper sulfate. Copper sulfate is blue, in the light blue coloration. When iron comes into reaction with copper sulfate, it displaces copper and takes the position as iron 2 sulfate, and copper has been displaced. Copper has been displaced. So Now that solution is the green solution we can see of ion 2. So this is actually what we refer to as displacement reaction. That is an example of a practical displacement reaction. Okay,